Hi everyone. This is example 10 from chapter 14 in your student packet. It says some students checked 6 bags of Doritos marked with a net weight of 28.3 grams. They carefully weighed the contents of each bag, recording the following weights. Do these data satisfy the nearly normal condition? So, first of all, notice that the sample size is rather small. We have 1, 2, 3, 4, 5, 6. So we have a sample size of only 6. And we don't know what the population distribution looks like. So in order to find a confidence interval for this, we're going to make sure that this follows a nearly normal condition. So it means we want to check the histogram for the sample. So enter the data into L1. And then from there, you're going to go to stat plot. So you're going to do second, and then you're going to choose stat plot. You're going to turn it on, and you're going to then arrow over to the histogram. Make sure it says L1, and then you're kind of done with that page. You're going to then hit zoom 9. And zoom 9 will create a stat plot. You want to make sure that all the other plots are turned off so that you don't have anything under Y1 or any other plots turned on. Now, at first, when you first look at this histogram, it does not look unimodal or symmetric. So you should zoom out. So go back to zoom and then choose zoom out. And then you will see that you get this pretty nice symmetric unimodal histogram. So because the histogram is fairly unimodal and symmetric, the nearly normal condition is satisfied. In part B, it says create a 95% confidence interval for the mean weight of such bags of chips. So now we're going to go to T intervals. So we're going to choose stat, then tests, and then you're going to choose a T interval. The difference between looking for a confidence interval for means versus a confidence interval for proportions is that the confidence interval for means is going to use a student distribution as opposed to the normal distribution. And there's some text in your book about the students' T distributions. But we use T when we're using means. So when you do this, hold on, I'm lining up my calculator. My T interval is number 8. We're going to choose data because we've already entered the data into L1. Our list is going to be L1. We don't have a frequency list for this, so the frequency list should say either 1 or it should be blank. And then we're going to have a C level of 0.95 because we're looking for a 95% confidence interval. And then when you choose calculate, you will get a confidence interval of 28.605 and 29.361. Remember that these are not percentages, these are means. So this is saying, and I guess we're doing this in part D where it says explain in context what your interval means. Let's just jump down to that. This is saying that we are 95% confident So we're saying that we're 95% confident that the true population mean for the weight of the Dorito bags is between 28.6 and 29.4 grams. Let's go back to part C. C is asking for the margin of error. And we're going to find this the same way that we found the margin of error for the proportion. Since we already have the interval, we know that the margin of error is going to be half the distance of this interval, half the length of this interval. So the margin of error is going to be 29.361 minus 28.605, all divided by 2. And if you're putting this all in your calculator, don't forget to put parentheses around the numerator. And so for this, we will get 0.378. Again, we are not talking about percentages here. This is a margin of error of 0.378 grams. For part E, it says comment on the company's stated net weight of 28.3 grams. So notice that the value 28.3 is all the way under, it's completely under the interval of 28.6 to 29.4. So we would say that the company is being conservative. The company is being conservative in its stated weight. So they're going to make sure that the actual weight of the bags is completely above this 28.3 grams.